So, in Germany we are against administration. The container is made out of metal to be as solid as possible, and the cover here is out of plastic so that it can be elastic, not break right away, and can be lifted easily. In general, what are the qualities of these organic materials? Well, certain ones of them are growing outside. Those are the natural organic materials, and in recent years they have been gaining importance because while growing they bind carbon dioxide, and well, when you burn them or you let them rot, the carbon dioxide is liberated again. But this is a major quality of growing natural materials. While plastic materials are mostly using oil as a basic material, we have three big groups of plastic materials. One are the duroplaste, which is mostly resin-based plastic materials. Then we have elastic plastic materials, rubber-like or the sort, and thermoplastic materials. So thermoplastic materials are often used to produce big series of elements because you can heat the plastic material, put them in a form, and then let it cool off, and it stays in this form afterwards. As you can see in these three drawings here, the elastic materials have very long molecular structure, and these are connected at few points so that you can elongate the material and then let it go back to its initial form again. Here for the hard plastic we have very short length of molecules, and they are very often connected. So once that the resin has hardened, then it becomes very hard and it burns rather than become plastic again after heating it up. And the thermoplastic materials I can heat up and then let it cool down afterwards. Very practical if I want to create complicated forms in a particular formwork. The thermoplastics are very good to create this multi-chamber plastic material, or this one, even more chambers. You can see very elastic. This is for waterproof cellar walls where I need a tight joint, and this can be inserted in the joint to waterproof it. And this is a resin-based duroplastic material with glass fibers inserted as reinforcement. Plastic materials are also very popular for additive manufacturing or 3D printing, because you can heat up a filament, which is a sort of plastic wire, and then it cools off right afterwards, and so you can create these interesting forms layer by layer. Plastic materials can be insulating. So in this case here you have an outer layer and an inner layer. It's a facade profile, and they are connected by these plastic connectors. The plastic connectors transmit the loads, but insulate a little, at least, between the outer layer and the inner layer. In any case, much more than the steel would do. So a particular application of organic plastic materials is plastic foam as well. Plastic foam, like for example this styrofoam, is often used for insulation purposes. So this is a thermoplastic material that you can heat up, then you put it in form of a foam, and then you let it cool down and it stays a foam. Here we have a combined plate of 2 layers of cement reinforced wood fiber and styrofoam in the middle. This is for acoustic purposes. It's an acoustic insulation plate. These plastic materials can be easily modified, so they have more potential in the modification era. In terms of material quality, glass wool, in this case here, and sheep's wool are quite similar actually, although this is a mineral material and this is an organic material. An interesting insulating material because it has a vacuum on the inside. So it's basically like your coffee bag, vacuumized. So it insulates much more than traditional insulating materials. But once that the vacuum is damaged and air gets inside, it loses its insulating quality completely. So it is often used together with another insulating material as a sort of tuning of this insulating material. This is a facade insulation element which takes a particular form. So something like this is easily be done in plastic foam and not as easily done in mineral wool, for example. So doorknobs, for example, would be a typical application of plastic materials. In this case, polypropylene coating on a metal support, and this could be made all out of aluminum as well. These two are offered as alternative products on the market. On this construction site protection, we are using plastic material. This plastic material ages not as nicely as others, but it's rather flexible. It's lightweight and can be easily transported to another location. So in construction we use a lot of films. The films might be only plastic, or they could be reinforced with reinforcement fibers, or the fibers could be solidified by a plastic coating, and this is normally the case where things have to be airtight or waterproof. So many of the window profiles are made out of plastic material as well. In this case, thermoplastic material, which is extruded, and because it would be too weak, it is reinforced with metal profiles on the interior. So one of the main problems of plastic materials exposed to sunlight is the aging process that can be observed in this publicity panel here behind me. Much more solid to make things like these out of metal, this is stainless and glass. If I compare a material like this to glass, it could be as transparent as glass. It's much lighter and it's much more elastic. But after a certain number of years, it will start to decay and be much more brittle than in the initial state. So if I want to have a very long-lasting product, I would rather use glass. If I want something that can be deformed in an elastic way, or which has to be rather lightweight, then I would opt for the plastic material. I'm at the chair for metal construction of TUM, and behind me we have a section of the roof of the Olympic Games 1972, and you can see that the cables are made out of metal. Then we have frames made out of aluminum, and transparent pieces of this roof are made out of sort of plexiglass, and they have been renewed after 40 years of existence completely, because the plexiglass became matte, and this is very flexible, so it adapts to the movements of the cable net behind it. And the joints here between those plexiglass parts are made out of a rubber elastic material as to correspond even more to the movement of the structure.